Okay, so again, if we're having trouble solving this one, I'm going to ask that in the back of your mind you kind of rewrite this as an algebra equation. So think of this as like x to the third minus x equals cosine. So it's not really x, it's cosine x, but if you understand how to solve this, if this looks familiar to you, then this is the same approach. So in an algebra class, hopefully you did a lot of factoring, and always factor out a GCF first if you can. So over here, our GCF is a cosine x. So if this was x, this being cosine x makes sense. You always want to factor completely, so I see the difference of two squares here. So this is an x minus 1 and an x plus 1. So this is a cosine x plus minus 1 and a cosine x plus 1. So you can see it looks more complicated, but it's exactly the same thing as this. So if you understood you need to factor this, and you can factor GCFs and difference of two squares, notice everywhere there's an x, I just have a cosine x. So not the same problem, but the same logic. Now I guess if I'd gone one more step here, this times this equals 0, when this equals 0, when this equals 0, and when this equals 0. So 0, 1, and negative 1. So then you're pretty much done if this was the algebra question. But in our case, we want to know where is cosine 0, cosine x equals 0, where is cosine x equal 1, and where is cosine x equal negative 1. That's where this equals 0, where this equals 0, and where this equals 0. So now I can think about one trip around the unit circle. You see cosine is 0 here and here. Positive 1 over here. And negative 1 over here. You can see you want to be very familiar with the unit circle here. You don't want to spend too long on that. So I could write four different statements here. I could say x could be this angle plus everything coterminal. Could be this angle plus everything coterminal. And how I make sure I get all the coterminal angles is that I get integer multiples of 2 pi, and then give me this angle plus everything coterminal, and give me that angle plus everything coterminal. Okay, so all four of those statements, though, if you were to check your answer in the back of the book, certainly not going to look like that, because in mathematics, of course, we always try to be as concise as possible. So notice these are spaced out by pi over 2 radians, but so are these, so are these, and so are these. So if these are all spaced out evenly, I can rewrite all of that into just one neat little statement. So I can start with the first one, and then I can say, instead of going plus 2 pi in, just go however much to get to the next one. So plus pi over 2 in. So add 1 pi over 2, add 2 pi over 2s, add 3 pi over 2s, add 4 pi over 2s, and then you start getting the coterminal ones. Now, of course, adding 0 doesn't really do anything, so I wouldn't include that as part of my answer. So the solutions to this equation, all the solutions that work, are any integer multiple of pi over 2.